Hi guys. Hi guys. So let's we talk about Pytorch in this class. Pytorch we will talk about basics and slowly we will go through advanced. Pytorch is nothing but in my words I will try to put it in my words. It's nothing but it's just a library means collection of objects which has an information. We can import this information to make a use of it and make our programs easier to calculate to do mathematical calculations and to make our program way more better. Okay, it all has collection of objects. That's it. Library has a collection of objects. It's a Pytorch is nothing but it's a Python library. Python uses it. It's a Python library. Only Python uses it, and it's developed by Facebook AI Research Lab. If you talk about specifically, it's open source library. Okay, it's used for everyone can use it easily. No need to pay money. No need to there is no restriction of sharing of data or anything like that, and it's used mainly for deep learning and machine learning. But if we talk about deep learning and machine learning, it's used most of the time for deep learning rather than machine learning, because machine learning has many libraries which is used for it. Because machine learning it's used in data visualization. Normally data visualization is where we predict future through data we have. And deep learning is where we try to get some other output or predicting data. We can tell sometimes we will try to classify things, sometimes we try to do some other things by doing all of things through images. It's not a written data with a word data, it's a images. Okay, there's a difference between these two. Machine learning, we use it to calculate using statistics and mathematical concepts. We use this to calculate the future chances of predictions, etc. But deep learning, we use mainly bits and bytes of images to compare it and to similarities. We use similarities, we can tell. We use similarities most of the time, and sometimes mathematical concepts for a output. Okay, why we use mainly and how it's used in deep learning models. Deep learning is a concept, as I told you. Deep learning models is nothing but we train test agents is like a information or data or images or something. I told you image, right? It's a images, collection of images is the agents. We train and test that to get the best agent, to get the best output, right? That's the data learning model. It's this whole process called model. Okay, it's application, a type of application, we can tell. Okay, then to build this application, we have to train the agents. We have to test that. This process is building, and you have to deploy this application. Means after building it, you have to bring it to the new outside of your own area, outside of your own restrictions. You have to give it to some others to try and test, to make sure that it's tested by externals to give a best output, to check its to get its best way to check its reliability, we can tell, etc. It's flexible, it's efficient. That's why we use PyTorch. And main importantly, researchers and developers use it for dynamic computation graph and GPU acceleration characteristics. The computation graph is nothing but normally we use graph, right? That histogram graph will be dynamically computation will be done for that graph in deep learning normally, as you know. For that we use PyTorch. As I told you, I'm telling you it's for Python. PyTorch is used for Python. It's a Python library. Okay. Okay, let's we talk about mathematical building blocks of neural networks. If we talk about this, we are talking here. Can you get what we are talking about here? We are talking about networks. Networks has, artificial intelligence is also it's a set of uh deep learning, machine learning, and subset machine learning and deep learning is subset of AI, right? And what does AI do? It is like robot. What does it do while doing operation? It will check if that person who got bitten by a crocodile. It check its photo, it checks its similarities, and check if it's bitten by crocodile, dog, or something like that, or if it's attish bitten, or if it's cutted, or if it's got infection. It's gonna check every single thing just through images. And sometimes you can't get exact output, 100% output. That time you're gonna go through data visualization, which is data. You're gonna use data, means you're gonna ask his symptoms, how he's feeling, how he was feeling when you got bitten, when he got bitten, that this information. Then he's gonna check the probability of getting bitten of which one. Then we are gonna compare two outputs and we're gonna get the best output and preference. That's how we use neural network. Network is gonna train and test. That's what training and testing agents, that process. We use some structure to do that. We use some ways of structure. Like example, if you go, students are going in a school, okay, they won't just go for college like that, right? If they want to get college admission, it's they don't just go like that. They have to go through 10th standard exam. They have to go through the teaching of one standard to first standard to 10th standard. They have to get their maturity to get to give 10th standard exam. They have to go through IQ test. They have to go through 11th standard, 12th standard exam. No, it's nothing. They won't. You won't stop there. There will be a entrance test. Some few members will attend other test, everything, and then they will go to college for admission. That's how it goes. To get some output, they need to go through few steps to train and test, and that steps, that the structure, data structure is called networks. And here we are talking about neural networks. That's it uses neuron characteristics, means human neural characteristics, to stay each other, to connect each other in a very well manner without losing data. That's why we use neural, because if we uses less data, and it will be connected, for it will be connected almost all of the time. It won't be less, it won't be disconnected. It's That's why we call neural. We use neurons here. And there will be nodes which connects, like you see, there will be nodes something like this, something, there will be nodes something like this, which connects like this, okay. These nodes are nothing but neurons. These nodes are called neurons. These nodes are called neurons. And furthermore, that's not it. There will be three step, okay. In neurons as well, there will be three step. And first step, and this is output. These two are output, and these two are input. This is how neural data structure will be placed, okay. There will be totally three steps inside. It have to go through these three steps, then it will get output, and the input will be taken here. It will first, you first give input, you have input, you did not give input, you give input here. Now it's gonna check if there is a loss of data or if there is error rate. Okay, I told you these are neurons, right? What does neurons have? Like, how can we know this neuron is exactly this one? It's the address of neuron. There will be address of everything. Like, see, I'm not just somewhere, okay. I have address of my home. Everyone has an address of their own home. Everyone has their own name. By these things, by just these things, we can know that this person is like this, okay. By recognizing my face, you can't call me like that. You can't call me easily, right? You need my name for sure. That's a address. That's the main thing which you need to know that this neuron consists of this data, okay. And every neuron has its own data. Every neuron has its own address. That address is called weights in artificial intelligence. What is weights? Weights is nothing but it always, almost, there is many theories for weights which we have, but mainly we have considered one theory. In that, the theory specifies that the weights should be always 1 or -1 to make sure that it's correct. And if it's something wrong, then we have to maximize the weights so that the answer could be less error rate and less loss of data. Loss of data means what? We don't have much data to analyze the situation. See, you need to know if a person is wearing mask or not. To analyze the situation, you need to know, you need to have more than 500 images of women, 500 images of men. But you have got only 200 men's and 100 women's. It's a loss of data or not? how can a machine, it needs thousand for sure images to get to know clearly, to categorize a person very much or not very much, to categorize, to train and test it. We need thousand images for sure, we know that, but we have a loss of data. So these things can lead to an output in wrong output or something, like less rate of output. To get exact output, we need more images, more data, and we can do that by increasing weight. We can manage the, we can tamper the weights and manage the data according to how we want, and we will do that here in this step. See, in this step we are gonna do that. See, in this step we are gonna do that exactly. See, do you see that? Here we are gonna take one input and we're gonna divide. Here we're gonna take one input and we're gonna divide it through several inputs. Neurons is gonna consider every single data and it has its own data that's called weight, and we're gonna tamper weights to change the error rates and the loss of data. Error rates means what? Error rates is nothing but it will be for some, how can I say, okay, let's leave the topic there. We will go, I will talk to you about errors after I finish this topic. See, then we're gonna check all of these things and we're gonna put it in here in these neurons. It's answer from these neurons to these neurons. Now neurons have correct weights, neurons have correct loss of weight, correct error rate, everything loss of data. Now it's gonna merge into one input, one output. If I talk about, it's gonna merge few inputs into one output. As much as we can, we will try to merge. Then we are going to merge everything to one output, so that we will get one output which is the exact output we want, exact output we want. Okay, and okay, this is called neural network. This is how structure of a neural network works. Okay, as I was telling you, what is a error rate, right? Error rate has many functions, you know. To calculate error rate, we need a forward backward propagation, etc., etc. And activation functions, it's used to take input, like, you know, to take input. Activation functions use like input hidden, output layer only hidden. These layers has names. See, this layer has name. Input hidden, this is the output layer, and only hidden, and this is one more layer. Yeah, output hidden. This layer is input layer. See, there are many layer names for this layers. Like this is how neural network is structured, and every single data, if needed, like output needed, deep learning or machine learning, it will go through this every neuron. Then it will go through all loss of rate, then we get accurate output how we want. Every single time it go through these three things. Okay, then we will get output exactly how we want from the input we have given, right? This structure is called, this is connected to each other. See, neural networks are connected, networks, neurons, yeah, neurons is there, right? These neurons are connected to each other, so they won't be disconnected. Never, never, it will never be disconnected. This is strong network which they found, which scientists found very useful. So they think that neural network can be used in future purposes, so they thought to introduce this in every single thing. So artificial intelligence was introduced through this neural network. Like using this neural network, artificial intelligence was introduced. What are we talking about neural networks in this thing? Like, you know, we're telling the building blocks of neural networks, nothing but how neural networks work, what are things used for neural network, etc., etc. We're going to talk about that, and this is a building blocks, like to build a neural network, what we need, how it works, why it's need, everything needs to be done, right? That's how it we're gonna go through this once by reading this. Tensors, the fundamental data structure that represents inputs, I told you. Weights, activations in neural network. Gradients, I did not talk much about this, but let me talk about it. The derivative that captures how small changes in the input, like, you know, not every inputs will be same, right? You have 500 images of women, not every woman will be same. Not every woman will wear mask in the same manner. Some people wear output, and some people wear like wrong, in a wrong manner. Some people wear fold it like this. There will be few changes, right? These small changes of input may lead to effects of weights, means address of neurons can be affected. It can go less or it can go more, which will lead to inaccurate output. So it's important to have a best input. We have to check first it's a correct input or not. That's what an input hidden layer does, right? Next, input hidden layer does these three layers. I told you that the three layers does, right? That's a gradient. This thing which is done is called gradient. And you know, gradient, it has one thing, like there's a function which is normally gradient users, we use that for what can I say, like graphing, to plot the graph or something like that. We use that example. Let me tell you the types of gradient descents. The types of gradient descents, okay, it's not like one gradient descent, there are types of gradient descents in there. See, model performs in a best manner when there is lesser error rate or actual prediction is done. Okay, if any of these things correct, if both of these is correct, then models perform in a best manner, right? And in an input hidden layer, we will have a problem of input hidden layer means, I told you, right? Three layers, there will be three layers, there will be these three layers. In these three layers, this is the input hidden layer. And see, that layer, in that layer normally there will be backward propagation. Backward propagation means what? It's nothing but where we, you see, input we got, we're gonna go through this layer, then we are gonna get to this hidden layer. Okay, this is the input hidden layer. We're gonna through, we will go through here, we will have error right, to correct the weight, how much ever we want according to the input. We need to change the input direction. Example, we have got two inputs here. No, we have to change that. We want two inputs not to be here, not to be here, but to be here, so that weight can be managed correctly, right? So do that, we have to go again backward, right? That's a backward propagation. Forward and backward propagation, where it manages weights by taking the neurons backward, because neurons will always be connected. We can go backward. It if it is here, you can go backward by making it here, and you can go backward by making changing it fully, right? Something like this, right? So that's how forward and backward propagation works. And we use forward and backward propagation to cost error function means to reduce the error, and to reduce the loss of data, and to readjust the weight in such a way that error rates go down to minimal value, right? So these things we use. And error is still higher, you see, if error rates are still higher, we should use binary entropy loss. Okay, entropy loss, it's called entropy loss. We use this thing entropy loss when if the error rate is still higher, and we can't make the error rate lower, and our prediction of output is not coming, we can use entropy loss. And to use entropy loss, there's a thing called gradient descent. That's where gradients plays role. Okay, one types of, there are types: batch gradient descent, mini gradient batch gradient descent, stochastic gradient descent. To see, we use this to smoothen the curve in algorithm, like this has a curve, right? See, it's working or not correctly. How are we gonna show to the other person? Like, you can't show this to the human. You can't know, she can't, she can't, no one can understand that this neuron has this data, has this other. You can tell that it has one address, it has this data. Can a person understand? No, you have to show that through graph. And that's what gradient do, we show through graph. But if the this curve is curved, if it's straight line, if it's like this, or if it's not joined. See, if those systems are not joined, these are the problems. Error rates, like we find out error rates like this. And we need smoothen curve, like curve should be smooth, so that means curve should be perfect, so that error should decrease, and error duplicate should not be done. These things are done through gradient descent, batch gradient descent, mini batch gradient, stochastic gradient. They are used to avoid the error rates. Okay, optimization algorithm. It's where we are going to optimize algorithm. Like, there are many big algorithms to reduce. We should reduce that, and as well, that's the main thing. Okay, and another thing is that why optimization algorithm came in this neural network point is they're telling that I told you stochastic gradient, right? Can you see that? Like, can you see that, guys? Yeah, this is a method. This is a mathematical method, or we can tell the algorithm which is used to casting a gradient is used to avoid error rates through making the chart curve in a better manner, right? Adjusting the network weights. See, we should adjust the network weights to minimize the loss. Okay, we should make sure that network weight is best to minimize the losses of the data and to reduce the error rates, right? This For that we use algorithm of this to make all of this to make sure all of this, and these algorithms are important in neural network. That's what we are going to do in neural network. We're just going to go through the images, we're going to scan it, then we're going to train and test, but training and testing is not as much as easy as you think. We should use many algorithms. We should go through the network structure. We should go through neurons. We should go through input. We should have input. We should go through weights, right? So these are the things which I'm telling. We need few important things. We have few important things in neural network which you need to know. I gave it as a introduction. That's why I gave this. Okay, we gonna talk real thing here. Why, how Python and neural network is related? That's what we wanna talk. Basic things I gave, not advanced things. Okay, I told you forward and back propagation, right? Here, can you see that? Can you see that the point is there? Forward and back. See, can you forward and backward propagation? Can you see that? Yeah, as I told you, Pytorch, you can instead of writing the whole program for forward and backward propagation, it's algorithm, right? Where you go, where you go backward of from here to here like this, instead of going forward, to make sure that you get less loss error rate by changing the way of connecting neurons, right? By connecting other neurons with more weight or less weight, doing like this thing, changing neurons of the with more weight or less weight can improve the output, can improve the loss of the can reduce the loss of data and the error rate, right? Yeah, that's a thing, main important thing. And pytorch has few objects, or we can tell that few keywords to access that algorithm. You don't need to write full algorithm for that. You just need to write that keyword, import from the pytorch library. You're gonna get forward web application full object uh, filled with a single keyword, and if you import that, you will get that. Okay, it's easy to experiment with different network architectures. That's why we use PyTorch in neural network basics, okay? In neural networks. And if we why mainly three reasons. One reason is over, another reason is autograd module, which is this one autograd module. As you see in PyTorch autograd module, what it does. Autograd module normally what it does, I did not told you, right? It tracks operations performed on tensors, enabling automation differentiation for building and training data neural networks. Means, you should track how it works, right? How it works, and is it working correct, and is it right? The tracking is the work what autograd module does. It performs most of the time in inputs, weights, and activations area. This automatically, but it's done not manually, it's automatically done. That means differentiating, building, and training. Okay, we will train, but differentiating the loss of rate means this has loss of rate, this has loss of rate, differentiated which has more by doing minus of it. These things, by doing minus of neurons weights, doing this we will know which is best one. This tracking operations, and we get to know which is best one is the main important thing. That's what autograd module will do. And pytorch has autograd module keyword as well, means object which you can access and import and you make use of it in a better way instead of writing the whole program on the algorithm like always we do in neural networks by using other languages, right? In python, that's why we use pytorch most of the time. For deep learning mainly it's used, as I told you. and constructing neural networks. See, as I told you, it's not just used for autograd module. Yeah, I was talking about neural networks. Who is going to construct neural networks? Like, you're going to tell that data input to go through these neurons. But where these neurons came from? You need to construct this structure, right? This structure you should construct first, right? This is input, this is output. You should construct this structure, right? First of all, you should link this each other. Every neuron should be linked to each other. This spider web or neural thing, you need to do every single thing. Then after you need to give input. It's like a program. You need to do every single thing through program. Then you need to give input. So it's gonna go through all of these things and give the best output. Okay. So that's how it works. And constructing this neural network as a program, and instead of program you do have a import keywords. You can use that, like layer activation functions, loss functions. You can use that to build a high level building blocks, means high level neural networks, right? Next, okay, universal workflow of machine learning and pytorch. As I was telling you, what's the difference between machine learning and pytorch? Machine learning is a thing which we mathematical calculations. It's those things we are gonna learn. AI is gonna learn. Models are gonna learn. That's the process. That process is called machine learning. It's a set, we can tell. PyTorch is a library. Okay, Python library. But what we're talking here is the universal ML workflow. Means data acquisition, pre-processing, model selection. I told you, right? Everything, every model goes through this, give these things, then it will give a best output. Yeah, what it will go through? Okay, deep learning we gone through. Deep learning just now we gone through. See, deep learning we will go to neural network. For deep learning, images and all scanning and then giving a best output, we will go to neural network. Neural network structure manages every single thing. You don't need to go through single step. Neural network, you write a code, that's enough, more than enough. It's gonna manage all single thing, all single images. It's gonna manage input. It's gonna manage output. And it's gonna give best output automatically itself. But it does not work for machine learning. Machine learning is like a data. You will have a data, you will not have a images. You will images also data. But if you talk about written word data, words data, then you will have symptoms. You will have a, how can I tell, records data, records, written records data. Okay, by using this data, how can you scan, how can you give a future prediction, how can you give a output from input? It has to go through steps, right? Just like input hidden layer and only hidden layer, these things, output hidden, these things are the layers which was in only neural network, right? Or those neurons, yeah, it has to go through these things in deep learning. But here measuring how it works, that's what we are going to go through in here. Few years we saw pytorch with deep learning, only deep learning. But here we're going to go through pytorch with machine learning, because I'm going to tell you about machine learning here and now itself. So let's talk about machine learning. Machine learning is nothing but learning, making machines learn. Okay, that's what we can tell indirectly. Nothing but we're going to scan in the in data, whichever is given, we're going to get a best output. Okay, that's the simple thing we can tell. Data acquisition, we are going to acquisition means we're going to acquire the data. We're going to collect the data first thing. What data? Examples, we will tell that, okay, we will take about disease. As I told you, the AI is going to scan disease, right? We're going to take where it got bitten, who bit it. Like he don't know who bite it. Okay, it's fine. When it was bitten, can he remember? Was it afternoon? Was it evening? You have to get the exact information. Then how many days after he came to you? How many days he was at home to save the money? And how much money he's gonna spend now? And how much money will be there to for the main position? You should need to check that to make sure that you get the payment in the correct way. And because you treat them, if you're a government hospital, you will treat them without any tension. But if you're not, if you're private, then you need to check money before the treatment, right? As it always works like that. Pre-processing, data model selection, data acquisition is done. You collected the data, everything. Now you know symptoms, like he has cough, he is getting a blood cough, something other symptoms, is getting urine, more in urine. These are things which he got symptoms. You're gonna collect this information and store it. This is a data acquisition. Then you know pre-processing means what? Pre-processing is nothing but we are gonna find out which column, like which person has a zero values, like he doesn't feel anything, he did not do that, he did not do this. That's fine, it's zero value, but no values. Zero is different, no value is different. No value means he did not told anything about that, how much ever we ask. That's a no value. That data acquisition, if the person doesn't get urine or get urine, we don't know, it's empty. Then we need to find out null values, we need to clear the null values. Clearing null value is we need to get the null values out of the value. Then we have to give value, at least we have to give zero, even if we can't give exact value, right? Then we're going to scale it. Then we're gonna do exact organizing it, everything we are gonna do. This is pre-processing. This process is called pre-processing. You're gonna get to know this clearly when we talk about machine learning specifically. I will talking about it when the time comes. Model selection, we're gonna select the model means you got different values, right? You got different symptoms, you got different data. In that you're gonna select one or two data exactly to make sure you can train and test for a future prediction of the model, right? Choose one or two data which you can depend most of the time. First data, when it got bitten. Second data, how many days after he came. Third data, we take three data, what are the symptoms. Okay, these are the three results which you have now. You're gonna check this, you're gonna classify this, you're gonna train it. That's the next selecting this thing, smaller selection, and they're gonna train it means we're gonna tell that you are the x, you are y value, and you too should reply like this. If you got problem like this, you should reply like this. You should go like, you're gonna train like this. We're gonna evaluate means we're gonna test it once ourselves. We are not going to let someone test it, but we're going to test it ourselves with this evaluation. Then we're going to we're going to let someone test it at last. Then we're going to deploy it means we're going to let everyone use it. The data everyone can use means everyone can do future prediction. They don't need to come to doctor if they have symptoms, something. If they have data with them, they can put it in application. Everything the application is gonna show about them, and it's gonna tell did they got bitten, are they gonna die, and how much are they gonna. Everything information can be predicted. Okay, that's a product. That's a machine learning work. Pytorch simplifies this workflow with initiative APIs for each step. See, we use APIs for simplifying the each step. Like pre-processing is not that much easy as you think. To clear the null values, you need to import few things from libraries, and if you don't import it, then there it is. You have to write every program for that import which you didn't do, for that algorithm or object. If you're gonna write like that, you're gonna write continuously. You can't finish it. To finish it in an easier way, you're gonna use APIs, which we from using Python as well. Next, from data handling to model optimization. Yeah, as I told you, machine learning focuses on building predictive models from data, while deep learning automates future engineering. It's nothing but machine learning mainly focuses on building predictive model. It predicts what will happen in the future. That type of model we focus on building. Machine learning focuses on building, but deep learning is not like that. It focuses more on automate future engineering using neural network. Means it will use neural network to do future engineering of automation. Means automatically everything should be done, but machine learning is not like that. You should give input, but deep learning is not that way. You should give input for machine learning. You should check the null value. Not no model means machine learning. You should check the null value. You should do pre-processing. You should do model selection. You should do training. You should write code for every single step. Every single step you should do code. That's why I told you APIs is used for every single step. Means we will do code for every single step, but deep learning is not like that. If you give input, that's enough. If you have neural network, give input to a neural network automatically does every single output prediction. It's gonna do automatically, then it's gonna give output, right? Python's dynamic computational graph excel at deep learning. See, deep learning, I told you why it's important. Dynamic computational graph is what is important. That's why we use it for most of the time for deep learning rather than machine learning. And even if you talk about machine learning, empowering researchers, developers to rapidly experiment with novel applications. Even if you talk about machine learning, the few things we use it for, like training and testing, we use it for those few things. Or graph, we will use it. PyTorch. PyTorch neural networks to functional blocks. See, what we are talking about, let's read and let's get to know. Modular approach. Python's modular approach building neural network are composition of reusable functional blocks, simplifying complex architecture. It's nothing but every thing has its own approach, right, to get output. The same way neural networks should have its own approach, and we are using pytorch. According to pytorch, which approach is best, we're going to go through. Modular approach is where we enable building neural networks as composition of reusable functional blocks. Means why we use modular approach means most of the time for pytorch. When we use python, that is, we build neural network once, but we can use numerous times the same neural network again and again. It still won't make neural network waste. It still won't change the neural network a little bit. It's gonna train neural network in a better manner, actually, simplifying complex structures. As you go on using it again and again, reusable for different things, if you use the neural network, it will make sure that it simplifies the complex things in a future in a better manner. Okay, that's why we use modular approach. Training loops. Training loops in Python automates the process of optimizing model parameters, leveraging powerful optimization algorithms like stochastic gradient descent. See, training loops is nothing but, I told you, right, this one. Ah, going backward, forward, going forward, going backward, going forward, going backward. These are loops. You go forward, backward, you go again, again, again. So make sure that you get the best output. This you till you get the best output, you will change something, you will do something. These are training loops. Loops means going again and again to make sure that going inside some block of code again and again to make sure we get the best output. Right, the same way this is how it works, and PyTorch is used most of the time for this purpose. Like stochastic gradient descent algorithms helps PyTorch to be more usable in the Python code for deep learning purpose. Okay, I talked to you about neural networks, but I never talked to you different types of network, right? There are types of networks. ANN is artificial neural network, and convolutional neural network, this one is. CNN is what? What if it means CNN? Other some other neural network. It's a built-in, okay? Convolutional neural network is a built-in. You can import convolutional neural network, okay? Such as conv2do as and maxpol to do 2D simplifies the construction of powerful image recognition model. I told you, right, mask with wearing mask, not wearing mask. To get this model, you can use maxpool 2D and conv 2D, which is convolutional neural networks. You can import this. If you import this, you can do it all on your own. It will just work on its own. Okay, you don't need to even struggle much. Okay, leveraging GPS acceleration, Python CNN can be efficiently trained on large scale visual data set. Means, I told you, right, deep learning machine learning has many different. See, machine learning, you're gonna get many data. You're gonna get many data set. It's gonna get many data set, right? Yeah, but but compared to deep learning or machine learning, deep learning gets many dataset. It gets many output input. For machine learning, you may need 500 or 300, 200 columns and rows to make rows for to get the best output. But it does not work like that. For as much as less you have, it's gonna give best output for your machine learning. But it does not work like that in deep learning. If you have large scale of input, then it gives best output, best and best output. See, when you have large scale of input, you don't need to use machine learning, so it's risky. Okay, you have to do every step by yourself. Every step you have to code. But deep learning is not like that. You can use it in a very easy manner. So you better use this when you have large scale of input, and it's more like image classification or object detection type of input. Okay. Then Pytorch recurrent neural networks. Pytorch RNN modules such as LSTM. See, this is another type of recurrent neural network type, like neural network type. It has few objects like LSTM, GRU, means algorithms, we can tell, enables the creation of powerful sequence models for tasks like language modeling, machine translation, and speech recognition. I told you, right? What's the difference between this one and that one? Convolution is nothing but you use the neural network when you need to do only image recognition models, means when you need to do image classification or object detection. But here we use this recurrent one when we use to do LLM, means language learning model, or language learning model, machine learning, translation, speech recognition. Example, translation. If you want to do some translation, you need this AI. Okay. Same way, for this thing, recurrent neural networks is used. If you talk about more deeper, integrating recurrent layers into complex architecture in straightforward in PyTorch, allowing researchers to focus on model design rather than lower level implementation. I told you, doing this implementation of recurrent layers in PyTorch helps researchers to focus more on model design, means how should we design the model rather than check every single small things. Like in machine learning we will check every single step, we are responsible for every single step because we code every single step is very important. But it must not work like deep learning. We can concentrate on more on input and outputs rather than concentrate more on steps or process or other hidden layers. This helps recurrent neural networks helps like in this way. Okay. By as I told you, and I talked about you about two neural networks. Then PyTorch, transfer learning and fine tuning. Transfer learning, PyTorch enables effortless transfer learning. See, why we are talking about transfer learning to fine tuning is we have to know how PyTorch works in transfer learning and fine tuning. If we talk about fine tuning and transfer learning, most of the time PyTorch is best at transfer learning rather than fine tuning compared to fine tuning actually, allowing you to leverage pre-trained models as starting point for new tasks, saving time and resources. See, if you give new task, if you give new task for a model which is already ready, which is already trained, if you give new task for that, it will take it as a starting point, but it saves time and resources. Why and how? Because it's already trained and it's already trained, tested in a different manner with a different outputs already many times. That's why it's a pre-trained model. Okay, with that, if we give new task even from starting point, even if we go give new input from starting point, which is almost a fresh complex, still it's gonna save time and do it faster, and we'll have enough resources and give a best output because it's a pre-trained model. Okay, that's the main important thing which is preferred in transfer learning. Okay, that's why we use PyTorch in transfer learning for this purpose, for saving time and the resources. Fine tuning means this model or this models on your specific dataset for further boost performances. It goes like it concentrates on more specific dataset, like single dataset. It concentrates on more on single dataset, and it boosts performances of many more things. This model is called fine tuning models. This type of models are fine tuning models, and it's where harnessing the generalized knowledge while adapting to your unique requirements. Means transfer learning is where you save time and resources, and here you boost performances through uh, through going every single data set one by one and get to know the knowledge clearly and adapt to your unique requirement. Okay. Okay, and Pytorch can be used, library can be used to make this learning in a very better way. The future of Pytorch and deep learning. Why Pytorch and deep learning is used in future a lot, and how? Continuous evolution means, evolution means we can tell the changes of person or changes of entire earth, we can tell. Okay, PyTorch continuous evolution means we are talking about PyTorch evolution. Okay, PyTorch means PyTorch changes or versions, we can tell something like that. It makes advancement in things like federated learning, quantum computing, and auto something, and main important LLM, language learning model. Deep learning, in deep learning language learning model, for this model PyTorch is used most of the time a lot. Okay, and quantum computing. Next, emerging applications. In future emerging applications, PyTorch is used for healthcare, robotics, and climate modeling, etc. Like in these fields. Okay, seamless integration means seamless integration means like a production environment. Okay, it's where PyTorch is used for rapid development of a PyTorch powered AI system. Means environment means what? Situation surrounding side. We're talking about surroundings of PyTorch, means we're talking about PyTorch improvement. We are talking PyTorch, every single component, every single algorithm we are talking. If these things are integrated, if these things are produced in a better way, if things are improved in a better way, then this develops a rapid development for AI learning and the other things. Collaborative community, yeah, these can help me most of the time for the future of communities. Okay, communities, we can create one more community as a PyTorch community, and many people can collaborate, many people can improve that, to improve many things in AI field and other fields and healthcare fields, etc. This community will lead to improvement of other fields and other evaluations, and everything, for everything, the only one backbone is PyTorch. And this helps deep learning in a more better way. This helps neural network to improve, which is gonna make our output best output forever, if we get something like that 100 percentage accuracy. What is deep and machine learning? Well, let's we know difference between deep and machine learning in a very better way. Deep learning is a type of machine learning that uses artificial neural networks to teach computers to process data in a way that mimics the human brain. See, deep learning is nothing but it's a type of machine learning. Okay, it's a subset of machine learning, we can tell, or something like that. It uses new artificial neural networks. Okay, means artificial means neural networks. Artificial means artificial intelligence neural networks to teach computers to process. It's where we teach computers to process data in a way or in a manner that human brain does. Means it's where we're going to tell computer to take the data and means input and give the output in the manner of human brain, means human neural neurons, in the manner of neurons, as a dendrite and nucleus has in our neurons. In that way you have to make sure that you manage the data. We're going to tell that to the computer. This situation is called artificial neural networks. This network is called artificial neural networks, and this is how it's used for deep learning. And deep learning systems can improve their accuracy and skills over time by analyzing more data without needing manual updates from human. Main important. Deep learning can be increased, can have more accuracy, can analyze more data, complex data, large data sets rather than machine learning, because we are not gonna go through every single line ourselves. It's gonna go through automatically if we build a good neural network. If we build a establish a good neural, if we create a good neural network, right? And this, we don't need manual updates. We don't need to update or change or introduce manually or write manually code manually, right? As humans can lazy around or invest more time on many other things. Example, researchers can have more time on other high level programs, high level things rather than low level things, right? Machine learning is a type of artificial intelligence that allows system to learn and improve from data without being explicitly programmed. Means you see, it's a type of artificial intelligence, means it's a subset of artificial intelligence. It's where we can learn and improve the data which is given, okay? We can learn and improve the data which is given, but without doing program from outside. You can do program code from inside itself, but you don't need to import any code or program from outside much. But here deep learning we need to import. We can't code for every single thing, okay? Even if we can, there are few restrictions as well. But machine learning is not like that. We can code, but it will take a lot of time. That's it. Machine learning can analyze patterns to identify fraudulent transactions. Deep learning can do many things like image recognition and something like that, language learning models, but machine learning can most of the time analyze fraudulent transactions. Example, Truecaller. It helps Truecaller to analyze how many scam calls are increased, how many call centers are increased, where it is increased, where it is coming from. They can analyze to detect the scammers, and login attempts, spam emails, etc. are done easily from using machine learning. Okay, thank you for your time. Thanks, guys. Bye bye.